Hello, my name is Roberto Riva. It's the 26th of March, and since we are all in self-confinement due to this malefic coronavirus, Jeff Locke, creator of StimMax, this biodegradable nanotechnology product, and myself decided to do a little video to show some lab tests, one professionally done by Interweb, PDVSA, and Rosneft, which I'll show here, and the other one that Jeff did in his house with his kids swimming in a pool, which shows the biodegradable and environmentally friendly quality of this product. And also I will show in this blackboard how it really works in very, very simple terms. Basically, the product itself penetrates the formation cavities and channels and pores, and dissolves all kind of solids and makes them free flow as a liquid, and on top of that creates a coating around these channels so the oil can flow freely in abundance, creating incredible mobility, call it wettability if you want, and increasing oil production substantially. Well, here we go with the first Interweb test. Before we go to the lab tests and home test to show how StimMax separates solids and liquids and makes oil flow, I'm going to do a schematic, very short presentation of how stimulation works. You have a product which comes in 55-gallon drums. You can use 6 for a shallow well, or 12 drums, or it comes also in totes of 330 gallons. You pour this inside the well, and then soon after you fill in the well with brine water. Assume this is a 3,000 feet deep well. Basically you would have like a cork of water mixed with a product in something called micellar that penetrates because of pressure deep inside the formation. But it's not only pressure, it's also the geophilic quality of the product itself, because its nanoparticles navigate in liquid much like electricity navigates in water. So it goes deep into a formation, much deeper than any other product, and it does two things. The first, it dissolves all solids. Basically, these nanoparticulates take solid obstructions and quickly reduce them to a free-flowing liquid, and they go out. These solids can be paraffins, which is wax, it can be asphaltenes, which is thick like molasses, and it can be scales, like salt, like shown here. These are, for example, scale salts. So basically, it's taken out. Then the channels and the pores are left, and the second quality is that it coats all the channels and the pores with this StimMax electrochemical reaction, and it stays there, making the oil flow in a nice clean channel which is lubricated, substantially increasing its mobility, like increases mobility. This is the thing, the most important thing. And the oil flow increases, and we have seen wells increase from 20 barrels a day to 300 barrels a day, and even a closed well for 5 years went from 0, obviously, to 80 barrels a day. Why? Because of increased mobility in the reservoir. It rejuvenates the oil reservoirs. Now let's go to the tests themselves. This is the test made by PDVSA, Interweb, and Rosneft. This is a professional one in which they poured StimMax into this beaker, and you can see in a short period of time, without heating, normally it is heated, but without heating, you had the separation of the oil here. In the middle you have the deposits of solids that can be paraffin, which is wax, which is dissolved, or asphaltene, which is like molasses and it's thinned, or you have carbonates, which is salts, which the nanoparticles destroy. All of them are converted into free-flowing fluids. And on the bottom you have the water. One particular thing is this product does not form emulsions at any temperature. And the most interesting thing is you see around the beaker this layer, this coating, which is the same coating that you would have inside the formation, covering all the pores and call it canals where the oil flows, after destroying the three things I mentioned before, after eliminating all solids. So it increases the mobility of the reservoir's oil substantially. This is one of the big advantages that we have. This was done by scientists and technicians in the Interweb laboratories, and they wrote the PAS 1000, which is StimMax, is a quality of StimMax. It says it was applied with El Furrial crude oil, which is, El Furrial is one of the largest oil deposits in Venezuela, and it cleaned, encapsulated, and formed a protective film that permits a great flow of crude from the formation. And they added, "We are delighted." Normally, scientists or technicians don't put their comments, but here they couldn't help putting it. And it's dated September 13, 2019, so it's only 6 months old. Unfortunately, in Venezuela, it's already over a year. We cannot do anything, even though we have many contracts to stimulate.
Good afternoon, Roberto. Per your request, I am filming this video for your benefit. It's so easy. I'm actually doing it in my backyard, and I have my son even swimming. What I have is the Plus Patrol CE 1224 pulled from this year. We're going to put StimMax PAS for paraffin, asphaltene, and sludge, or scale, I should say. And we have 500 milliliters of Plus Patrol, and we're going to insert 20 milliliters of PAS that's already been pre-inserted into this little jar. I'm back, Roberto. I'm actually going to insert the PAS. Again, that's 20 milliliters. And you can immediately see how it's already separating. You got 3 levels of separation. I'm back. I just put the cap back on, and with some slight agitation, let me just stick it up for a little bit, swirl around a little bit. See how the oil that was sticking to the sides of the glass is automatically coming off. You can see the water separating out of the oil. You can see a sediment layer between the whatever was in the oil and the water, and then you'll see the crude actually floating on top. Again, the benefit of our product, as you know, is to improve flow, and this is a real simple experiment that just shows the separation, the lifting, and out the door it goes. The protective coating you see on the glass will be the same kind of protective coating you'll see inside the reservoir, within the pores, and any kind of water and oil emulsion or oil and water emulsion won't stick to the walls, again, enhancing flow. Round 2, Roberto. I'm taking a look at the crude from Peru, pulled on February 17th, 2020. lot number 12012. Again, I'm taking 20 milliliters of Taz, and I'm going to inject it into the crude samples that was sent to us. You're going to immediately start seeing, again, the separation breaking down. Let me agitate it, and I'll turn it back on. And the Peru samples are already starting to break down. I will add water. I'm going to add water to the Plus Patrol because theoretically, as you can see, nothing is sticking. What we'll do is we'll just assume that we're using a water or a brine or even a diesel for that matter as a displacement, and then watch the separation begin. Okay, Roberto, now I'm going to throw in, let's pretend there's some displacement going on. I'm actually putting in around 1,000 milliliters of water. This pushes the product deep into the reservoir to get into all the pores. Again, think nanoparticulates. And it's going to start stripping and breaking any emulsion. It's going to restore permeability, and we'll start shrinking the clays. Yeah. Well, Roberto, upon some agitation, again, you can see how how this layer is coming up, this layer is coming down. There's a sediment layer in between, and the whatever leftover crude that's still sticking to the walls of the glass are slowly peeling off. Again, I hope this is helpful. As with the Plus Patrol sample, where we added about 500 milliliters of water, we've added around 200 milliliters of water to the Peru sample, and you can see how it's breaking down. I'll do some agitation. With a little agitation, totally dislodged. Again, hope this is helpful.
The last two test photos are what happens in the well. After soaking for 12 to 24 hours, you will have a layer of oil, the solids in liquid form, and the water. And this is how it will happen in this particular well or any other well. Well, I hope this little video was not that long for you and explains very clearly what it is all about. And I hope to see you soon in the fields when we are free to leave after this long self-imposed isolation, which after a while starts to become a little annoying, to say the least.